International Physics Olympiad year 1984 IPHO. Problem number 1. Question A. Consider a plane parallel transparent plate where the refractive index n varies with distance z from the lower surface. See figure shown. Show that NA multiplied by sine alpha equal NB multiplied by sine beta. The notation is that on the figure. Question B. Assume that you are standing in a large flat desert. At some distance you see that appears to be a water surface. When you approach the water, it seems to move away such that the distance to the water is always constant. Explain the phenomenon. Question C. Compute the temperature of the air close to the ground in B, assuming that your eyes are located 1.6 meters above the ground and that the distance to the water is 250 meters. The refractive index of the air at 15 degrees Celsius are at normal air pressure 101.3 kilopascal is 1.000276. The temperature of the air more than 1 meter above the ground is assumed to be constant and equal to 30 degrees Celsius. The atmospheric pressure is assumed to be normal. The refractive index n is such that n-1 is proportional to the density of the air. Discuss the accuracy of your result. International Physics Olympiad year 1984 IPHO. Problem number 2. Cycling. In certain lakes there is a strange phenomenon called cycling, which is an oscillation of the water. Lakes in which you can see this phenomenon are normally long compared with the depth and also narrow. It is natural to see waves in a lake, but not something like the cycling, where the entire water volume oscillates like the coffee in a cup that you carry to a waiting guest. In order to create a model of the cycling, we look at water in a rectangular container. The length of the container is L and the depth of the water is H. Assume that the surface of the water to begin with makes a small angle with the horizontal. The cycling will then start, and we assume that the water surface continues to be plane but oscillates around an axis in a horizontal plane and located in the middle of the container. Create a model of the movement of the water and derive a formula for the oscillation period T. The starting conditions are given in figure above. Assume that C much less than H. The table below shows experimental oscillation periods for different water depths in two containers of different lengths. Check in some reasonable way how well the formula that you have derived agrees with the experimental data. Give your opinion on the quality of your model. The graph below shows results from measurements in Lake Vättern in Sweden. This lake has a length of 123 kilometers and a mean depth of 50 meters. What is the time scale in the graph? The water surface level in Bastudalen, north end of the Lake Vättern, and Jönköping southern end. International Physics Olympiad year 1984 IPHO. Problem number 3. Electrical filter. An electronic frequency filter consists of 4 components coupled as in the upper figure. The impedance of the source can be neglected and the impedance of the load can be taken as infinite. The filter should be such that the voltage ratio U out over U in has a frequency dependence shown in the lower, where U in is the input voltage and U out is the output voltage. At a frequency F0, the phase lag between the two voltages is 0. In order to build the filter, you can choose from the following components: 2 resistors 10 kΩ, 2 capacitors 10 nanofarad, 2 solenoids 160 millihenry, iron-free and with a negligible resistance. Construct by combining 4 of these components a filter that fulfills the stated conditions. Determine the frequency F0 and the ratio U out over U in at this frequency for as many component combinations as possible.